Okay, so we're still looking at the idea of similarity, but today I'm going to be working questions 23 through 26. All right, similarity in parallel lines. Okay, so let's take a look at number 23. Sometimes triangles, you guys see how two lines are parallel, but it's with some triangles in there. Interesting part is that my lines have one side that is all numerical and one side that is not all numerical, right? There's an X in there. And the instructions are solve for X, so it makes sense that I have to solve for that. But let me take a look at the side that is all numerical. There are three informations there. There are three measurements there. I can only see two. I can see that the values of two measurements, but there's really three measurements. There's two small measurements and a big measurement. The two small measurements, when I add them, is equal to the big measurement. In this case, the big measurement is 6. You guys see it says the whole side is 6. The two small measurements that I'm referring to, one of them is 4, and the other one is right here. So there's really three measurements. There's two small measurements and a big measurement. The interesting part is when I add the two small measurements, it is equal to the large side, the large measurement. So I'm going to say this small side right here is 2. Before I continue, I'm going to say the pictures are not drawn to scale. So I know that 2 looks less than half of 4. Yeah, my pictures are not drawn to scale. But when I was looking at this thing, I said, I'm focusing on the three measurements. When I add the two small sides, it is equal to the big side. Now, why do I care about that? That's going to make it easy for me when I solve for my x. Now, on the side that has x, those are the two values given. So I'm going to make a fraction using those two values, x plus 3 over 4. And I want to let this equal to the corresponding measurements on the other side. Now, x plus 3, if you notice, and 4 are the two small measurements. The big measurement will be the whole side. Now, I'm not using the big side, right? Therefore, I'm not going to use the 6. Did you guys see what I did? I was not using the big side. Therefore, I'm not going to use the corresponding 6. Now, x plus 3, if you notice, it goes with this 4. 4 goes with this 2. And then I know how to cross multiply it. So let me do that. Let me cross multiply this way. Because of the plus sign, the number that is by itself, in this case 2, I'm going to go 2 times x and 2 times 3. So that's going to give me 2x plus 6. Now the plus sign, because it was there, right? So if it had a minus to begin with, I would have said 2x minus 6. So notice how I went 2 times x and 2 times 3 equals. And then here I have 4 times 4, which I know that as 16. Now the rest is just plain algebra. Let me separate my sides through the equal sign. I want to have the 2x by itself. So this plus 6, let me move it over as a minus 6. Don't forget to switch the sign. So that gives me that 2x is equal to 10. Right? 16 minus 6, that's how I got the 10. Now let me divide both sides by 2 to get the x by itself. 10 divided by 2 is 5. My instructions say solve for x. Well, guess what? X is equal to 5. Not bad. Let's take a look at number 24. Let me focus on the side that is all numerical. So I'm looking at this thing. Okay. 6 and 10. Those are the two measurements. But remember I said there are three measurements, two small measurements and a large one. In this case, I'm going to say the large measurement is 16. Because remember when I add the two small measurements, 6 and 10, have to add up to the big measurement, which is 16. Okay. Now from the side that has the x, I'm going to use the values 9 and 4x. Okay, so let me make a fraction. It doesn't matter where the x goes. I'm going to put it on top. So I'm going to do 4x over 90 equals. Now, when I pay attention, the two small measurements here, I'm not going to use one of them. Now, this side that I'm not using is corresponding with this 10. Those are the measurements that I'm not using. Okay. So 4x is going to go with 16, and 9 is going to go with 6. This 4x is going to go with 16. 4x is the entire side, so 16. And this 9, if you look at it as a street, that goes straight to 6. Okay. Let me cross multiplied. 4x times 6 is 24x. Nice, it doesn't have the plus sign now. Now, this other way, 16 times 9 is 144. Let me divide both sides by 24. So I'm going to get that x is equal to 6. Okay, so there were some triangles. There were parallel lines. But let me flip the page. Let me take a look at number 25 and 26. There's going to be some parallel lines, but not the entire triangle. That's fine. Let me look at the side that is all numerical, and I'm going to say this side right here is 10. Because remember, when I add the two small measurements, it is equal to the big measurement. So 4 plus 10 is equal to 14. Now, looking at the side that has x, these two values, so I'm going to write 2x plus 7 over 15 equals, now 2x plus 7 is the big side, so that's going to go with 14. Right, this whole side goes with this whole side. Now 15, if you look at this going straight, 15 goes with 10. Now what would 4 go to? With this side. If I knew this small side, this side goes with 4. But I'm not using that, right? So I have my two fractions. Let me cross multiplied. Let me go this way. Because of the plus sign, I'm going to go 10 times 2x and 10 times 7. So that's going to give me 20x plus 70 is equal to, now this other way, 15 times 14 is 210. So let me separate my sides through the equal sign. On the term that has the x by itself, I want to get rid of the plus 70. So this plus 70, let me move it over as a minus 70. So that gives me that 20x is equal to 140. Right, 210 minus 70 is 140. Now let me divide both sides by 20. Let me see, 210 minus 70. Yeah, now let me divide each by 20. And I'm going to get that x is equal to 7. Good, that was not bad. Let's take a look at number 26. Looking at the side that it's all numerical, let me just say that this big side right here, it is 8. Right, because 6 and 2 combined is 8. Now looking at the side that has x, the two values that I'm looking at are x plus 2 and 3. So I'm going to write this as x plus 2 over 3. Now, I don't have the big side, right? So I'm not going to use this 8. X plus 2, if I look at this as a street, it goes straight to 6. And 3 is corresponding with 2. So I'm going to have here the 6 over 2. Right? X plus 2 goes with 6, and 3 goes with 2. Now I'm ready to cross multiply. Because of the plus sign, I'm going to go 2 times x and 2 times 4. So that's going to give me 2x plus 4 equals 18. Oh, and the 2x by itself, so this plus 4, let me move it over as a minus 4. So that gives me that 2x is equal to 14. Let me divide by 2, and I get x is equal to 7. Not bad.